It's very dangerous for people to have an illusion that nobody observes their IP address. There will be always that somebody. They have a choice of who this somebody is.
Hello, everybody, and welcome to Techlore Talks. Today, I'm really excited to have Evgeny on, who's the founder of the SimpleX Chat platform, but it's also more than chat, as we'll talk about a lot today. He's going to talk about the decentralized network and how it works, the privacy and security implications, why this decentralization exists and how it's different from other decentralized models, usability challenges, multi-device functionality. Pretty much, if you've never heard of SimpleX, or even if you have heard of it and you want to learn a lot more about the nitty-gritty details, this is the place for you. Of course, we're going to zoom out a bit too and touch on the broader implications of privacy technology in society and the challenges faced by developers in navigating the legal landscape. One small disclaimer, Evgeny does reference other projects like Session and Signal quite a bit, and this interview was recorded a couple months back before things like Session's V2 protocol concept was released. So please keep that context in mind as Evgeny covers it. And now to the interview. Welcome to Techlore Talks. I've been meaning to have you on for the longest time. Do you want to introduce yourself and say a few things?
Hi, Henry. Thanks a lot for having me here at your show. I'm Evgeny. I'm the founder of SimpleX Chat, that many people believe is the most private and secure messaging network. We've been working on it for almost 4 years now. So yeah, I think everything that happened with me before is not so interesting.
Got it. Yeah, so when I put in SimpleX into my search engine, sometimes your messenger does not pop up. So do you mind explaining the name of SimpleX and the origins of that and the branding?
Sure thing. So we came up with a novel design for the messaging network long before it even started as a project. It was probably late 2019 when this design emerged. The idea was to create a communication network when people can connect without having an identifier on the network. That kind of flips the traditional network design completely upside down, to the point that when I was kind of explaining the idea to many even technologists, they were saying, man, you must be lying. It's just not possible because you need to some identifiers to connect to people. So, and the reason it got SimpleX name for two things, right? So first, it's simplex means unidirectional, as opposite to duplex, right? You know, like all those old ham radios when you have to press a button to talk and it transmits signal only in one direction. And also high security networks are also designed as unidirectional network when the data can flow only in one direction. So the whole network is constructed from rather simple messaging pipes or queues that can only transmit messages in one direction. And to have a conversation, people have to have two of those. And literally every single connection of the network is constructed from two of those pipes, and they can use different servers, actually a pair of different servers each. So yeah, so that's where the name SimpleX came from originally. And then we made a pun on like Simple X, because kind of simple. It's probably the simplest message queue design I've seen, comparing with the existing message queue designs, and also X for secure. So that was the origin of this name.
Very nice. And yeah, for people who looked it up, I went in there. It is not the crypto thing. It is the SimpleX Messenger. That is
correct. Yes.
Just to be precise, because yeah.
Correct. We call it SimpleX Chat. Yeah, and it have nothing to do with simplex cryptocurrency. Yeah, even though some people get confused. And many people say, when on earth are you going to change the name? And a small hint to the future, this will happen, obviously, and SimpleX will remain as a name for the underlying network, but we're going to consider, kind of have a good candidate for a new name for the app that may land.
Got it. No, I definitely want to touch more on that, because it sounds like, to myself and many people, when I say SimpleX Messenger, it's kind of just all one thing, but it sounds like it's a bit more nuanced than that. So I definitely want to touch on the architecture side of things. Before that, what's your team size? Where are you guys based? What's your structure?
We have a very small team. At the peak, we had 6 people, and currently we have 4 people in the team. So we're trying to be as lean as possible without any single geographic location for the team. Everybody is in different places, which we're not advertising. So I'm personally in the United Kingdom. The company is registered in the United Kingdom, which draws lots of criticism for which I disagree with strongly. We can talk about it if you're interested.
We can talk later
But
about
yeah,
that.
so I honestly agree with the view that was recently published in some post that jurisdiction doesn't really matter if the code is open source and the network is decentralized, and nobody should care about where this is all happening.
Got it. And so, to someone new to this podcast, before we start diving into the technical stuff, just very quickly, what would you define as the core difference between your messenger and just a typical mainstream messenger, something like WhatsApp or Facebook Messenger or even Telegram?
We don't even see what we built as a messenger, to be honest with you. We created a new network topology and design for transmitting messages over this network topology. But messages is a building block for any internet application, right? And it doesn't matter what it does. It can be access to content, it can be communication, it can be any commerce activity. And we just wanted to build the fabric for those applications, which would allow people to build decentralized applications that can work over the internet, providing people out of the box authentication, so you know who you're talking to if you connect it, at the same time providing them security from the network operators, so that while users have security and authenticity between them, the network operators don't really know who uses their network, and they shouldn't know that, because otherwise that undermines security of the users. So, and that's a fundamental difference. So we're not a platform, and we're not a messenger, and we're not a service. We created an application that philosophically is the most close to the web browser. Currently, there is only this new generation of application which we develop, but it doesn't mean somebody else can't create this application and connect to the same network using this application, and anybody can run the servers, and anybody can have conversations or communities or channels. And currently, the biggest development that's happening right now is a robust support for large content channel or large communities, which was the biggest point of criticism, because the network wasn't built for large communities. So yeah, so I think fundamental difference from WhatsApp or Telegram is that they own everything. They own the users, they own the content that users post, they own the conversations, and they can do what they want. And with us, we are see ourselves as a technology providers, right? We don't own the content, we don't own the users. We are developing technology which people can use to create and to have conversations between them, to distribute content between them. But our role here is effectively a user agent. Like the browsers are called user agents, right? So something that allows users to connect to this network, and we develop client software and server software, but we do not see ourselves, and we are not a service provider on this network.
Got it. So why have you taken this approach then? What do you feel like is missing from the space? Like, what's the value that this brings a regular person that you're seeing?
Well, OpenWeb is the only decentralized network design that really managed to become mainstream. And OpenWeb is still to date remains the network design which gives its users the largest amount of freedom. How can they use the network, right? You don't even think about it as a web. For most people, web is internet, right? And when they use the browser and go to some website, this website can do anything they want, right? I mean, not any specific website, but generally the web as a network can provide any sort of utility, right? It's not seen as something to access content only, right? There are social networks that run on the web, there are commercial sites that run on the web, and there is no limits to what people can develop using web as a network. But web has kind of reached limits in its development because of bureaucracy, because of lack of vision for what the web should go further. And we see more and more that the web is being replaced by large centralized applications. And a lot of user activity is now centered not around the open web, when they control, like, you remember the old days? I do remember the old days. You create a website, you're the webmaster of this website, you control this website, you own this website, you have 100% ownership of what happens on this website. Yes, it's very basic, it's rudimentary, but you own everything you put there and your own connections with people who come to your website, right? And now if you create a community on, you name it, Facebook, Discord, Twitter, whatever, right? You don't own this community. The platform does, right? You can do only what platform allows you to do. This platform can take it from you at any point. That's what we want to fix. We want to build a network when people own what they create, when people own connections with users they create, which gives them exactly the same utility they can get from Facebook or from Twitter or from Discord, but without surrendering ownership to content that they put there and without surrendering ownership of the connections with the users that they built. It's effectively, I've been saying to my supporters, investors from day one, like that we're not building a messenger, we're building the next web, the network that enables connections between people, the network that facilitates distribution of content and information in the same way as the web does, but accounting for evolved expectations and requirements, because we don't want to author HTML anymore. We don't want to just publish documents. We want to exchange messages. We want it to be much more interactive and instant, right? So you can think about it like new kind of instant web.
Yeah, so, okay, I'm getting it, but it's not very tangible to me and probably some people listening. So can you maybe just give a short example of what a day in the life might look like for me if, looking 10 years ahead, if the SimpleX network is widely adopted, how does this look?
I don't know. Honestly, I have no idea what 10 years from now will look like. But
the closest thing that you're describing to me is if I want to host a website on OnionShare. I open the OnionShare desktop app, I load all the HTML documents there, and then it's kind of going through, it's onion routed, it's decentralized, and then someone else via an onion link can access my website. But how is what you're doing different for that, and definitely hopefully more streamlined than that?
Correct. We don't want people to be technical to be able to build those communities. We want to provide people some composable primitives to construct the point of presence on the internet. We can call it site, right? So for example, your site can be just your channel, right? You publish your posts there daily or hourly or weekly, and people can come and read them, and people can come and comment there. So it's indistinguishable from your Twitter feed.
And how would they access that? Is that accessed via the ClearNet, or do they have to have something that utilizes like a SimpleX protocol?
We're actually going to offer both. And when you say ClearNet, SimpleX, we're not sure what we call ClearNet, right? So yes, it will be something that utilizes SimpleX protocol, but we are going to offer option to the owners of the channel to make them viewable via the browser. So let's say if you created a channel and you wanted, because there are pros and cons, right? By making it viewable via the browser, you get more people access your content, but you don't know who they are. You don't have any feedback loop with them. They can't comment. So some channel owners may not want it, right? Some channels owners may want to only offer a preview of the channel and say that you have to join via this app to connect to this channel, right? So it will be also, what we are saying is that ultimately the owner of the content or of the channel or of the community should make 100% of decisions. What is the user experience of people who come to this community? Do they want it to be just a stream of content? That's fine, that will be possible. Do they want it to be a group and people can participate and comment? That will be possible. Do they want it to look like multiple rooms when they can have multiple conversations, which may be interesting for large communities, right? If your community is over 100,000 members, then you probably don't want them all to talk in one room. You want to offer them some variety of ways they can consume information and engage with each other and with you. So what we will give people, you can think about it's like a modular constructor to put these elements together and make it look. I think the closest analogy you can think of is a Discord server, but with 10 times more flexibility about how the user experience will look like for people who come to you.
Got it. And so
that's if I look in many years ahead.
Yeah. I assume so. And I definitely want to touch on, I guess, timelines for things and what the future looks like. But when it comes to the architecture and then kind of the federated aspect of this, how does the whole relay server model actually work?
I think federation is the wrong term here, because federation is by definition, is a unity of multiple networks, right? So to federate, you have to have multiple isolated networks that decided to connect with each other. And that happens if some owner of the server or some operator has multiple user accounts, and they can all talk to each other using this particular server, right? And the network is not federated yet. And to make this network federated, there will be some other operator with its own users, and then they can allow users of each other to talk to each other, and that's what we call federation. But each of the server owners, they own their own cluster of users and conversations, and they can decide to leave this federation or join this federation or to restrict federation with some operators. And we see how it leads to actually more censorship in federated platforms than in centralized platforms, right? If you compare the level of censorship in Mastodon, it's stronger than in some centralized platforms, exactly because censorship decisions of multiple operators of Mastodon multiply each other, right? So as if I own the server, I can decide to censor my users, right? But I can also decide to censor users of another server, and I can also decide to censor the whole server if I want, right? So in a way, while federated model kind of promised initially more freedom of speech, it de facto resulted in less freedom of speech than some centralized platforms, just because moderation decisions, censorship decisions of different operators, they compound with each other, right? They add.
Yeah, I guess it depends on the definition of freedom of speech, because that can vary a lot. Like I know some people's view of freedom of speech is that it's just from the government, and so by their definition, actually a Mastodon person deciding how they want their platform to be run is actually a perfect use of freedom of speech. But I can understand how to a user, in terms of, whatever they say, they don't know if it's going to be blocked by the platform or not. Federation gives them actually a little bit less control than some centralized platforms might. So yeah.
Exactly. So what we did is not federation by this definition. We see operators, server operators, as there are no user accounts, right? And the user is not attached to any particular server. From the point of view of the servers, users don't even exist. All servers know about is this small, dumb, unidirectional pipes that transmit messages. It's user devices that know which pipes to use to reach their contacts, to reach their friends, and to reach their communities. And the user devices know how the network is organized. But server operators don't know any of that. They simply provide the messaging pipes. And currently, like if I talk to you on SimpleX, we'll have one messaging pipe depending on one operator. And that obviously creates some problems with reliability, because if this server goes down, then we can't talk anymore, etc., etc. So we obviously plan that it will be using multiple servers of different operators and also automatically rotating them to create reliability from any like technical malfunctions or from some unreasonable censorship decisions. So I think it would be fair to say that the design we're moving towards from the very beginning would be closer to Nostr design, which is also not federation, right? So rather than choosing which server to publish a content on, and then let servers decide how the network should function, right? That's the federation approach. It's effectively the network of servers. Nostr takes another approach. You as a user decides which servers to use to publish your content to, and the network is formed by the users, not by the servers. And the SimpleX has similar approach to network topology when it's users who decide how network is structured and not the servers. And servers don't even know about how network is structured, because all servers see is connections, but they don't see the nodes of the network, right? They don't see how those connections organized are into the network. And the users are free to rotate, change operators, use multiple operators at the same time. So effectively, we want network operators to be a disposable, redundant, portable commodity, right? That you can buy off the network, or there may be some free capacity allowance to you, but you effectively buy it as network capacity rather than as a service from a particular company. So you don't necessarily choose one company. Like if you use email, you have to choose a mail provider, right? If you use Mastodon, you have to choose your Mastodon provider, right? If you use Nostr, you don't have to choose which Nostr provider you use because you use multiple. And SimpleX has similar approach to the design. You're not choosing which network provider to use because you can choose the long list of them to use and use them all at the same time. And some conversations will use one operator, some other conversations will use other operators. And the future will look like each conversation will use more than one operator concurrently in parallel to provide redundancy. It's already using multiple operators today, right? So like because there is a direct messages, response messages, they would use different servers of different operators already. But in the future, there will be redundancy in message passing, and every time you send the message, it will be sent via several channels to ensure that it reaches the destination, even if one operator has malfunction.
Got it. And so to make this more tangible to especially myself, but I'm sure some people listening as well, can you maybe go through the different models? Because right now, it's pretty confusing for people, especially if they're not more technical. Do I use Session? Do I use Signal? Do I use SimpleX? So can you kind of walk through very, very briefly, like we don't need to get super thorough into each one, but what does the model look like when someone registers for Signal? And how does that compare to Session? And how does that compare to you guys? What's actually going on behind the scenes?
So look, Signal has managed to build a fantastic product that everybody uses as inspiration, and they designed a cutting-edge protocol algorithm for end-to-end encryption called also Signal, which people obviously confuse with Signal, the product, right? But the Signal protocol remains state-of-the-art in end-to-end encryption, providing some very important qualities, right? And we use it as well. We also use Signal algorithm. We have slightly different approach to post-quantum encryption. I think what we do is a bit more secure than what Signal does, but Signal recently improved and caught up to slightly better level. So when you go to Signal, you know what you do. You provide your phone number, right? And Signal verifies that you're the owner of this phone number, and they create a username for you, and that creates your account on Signal. And when somebody wants to connect to you, they have to go to Signal servers. They can't go anywhere else. And Signal would effectively see, inevitably, because that's how network functions, who connects to whom and how often messages are being sent. At some point, Signal introduced the interesting cryptographic scheme called sealed senders that was supposed to hide information about who talks to whom. But long story short, it doesn't work. I mean, it is not providing protection on all system layers. It only provides protection in a specific component, but not in the system as a whole. And it also is vulnerable to statistical analysis. So I would strongly, I can comment more on that if it's interesting to somebody. But generally speaking, we should consider that it's not something that really works or provide any meaningful protection. So fundamentally, Signal knows what's your phone number and knows who talks to whom. So while Signal provides very strong content privacy of your messages, Signal does not provide protection of your contact from itself and from any party that may get access to Signal information.
Just a quick note there before we move on to Session. How come if a government, asks Signal for what they have, they only give 2 pieces of data?
They might be not holding it. I don't quite understand was there a compliance requirement and for how long they are supposed to store this information. But if they're diligently deleting this information, if they're sticking to their privacy policy, then they obviously would not be able to provide this information on request. It doesn't mean that anybody who compromised Signal can't access this information. It doesn't mean that some malicious party inside Signal can't make a recording of this data. We're talking about possible attack vector. It's not about what actually happens. So I do strongly recommend people in many cases use Signal. We use Signal as a fallback channel if something happens with our servers, right? So Signal is objectively is one of the best products out there because of its longevity, because of how long it was developed, because of how much money was spent on developing Signal. So I certainly do have very strong recommendation to use. But people have to be realistic. If they do not want their communication provider know who they're talking to, which may be very important for a large category of people for different reasons, then they shouldn't use Signal, right? Or for example, if people do not want to be reached via Signal, because Signal allows to reach out to any user who you know the username of, right? Or the phone number of. And you know what spammers do, they just guess, right? You don't need to know, you just send messages to multiple numbers, some of them respond, and then you can build various scams or attacks or whatever, right? So SimpleX in comparison makes it an option. You can create an address, a public address that multiple people can connect to, but it's an option. It's not a requirement. You don't have to have such address. And even if you created such an address and suddenly you start to receive lots of spam via this address, you can just disable this address. You will not lose any of the contacts that you created via this address before. So in SimpleX network design, we see address that you created as first optional and second disposable. You can delete it without any consequences to already existing conversations.
Very cool.
With the Signal, your address and your contacts, they're all intertwined. You can't delete your address, right? If your address became public, you may start receiving spam. There is nothing you can do other than change into this address, and that will undermine all your existing connections. So that's the problem with any design that requires users to have an address.
And then what about Session?
The Session started as a fork of Signal Up, which was great. They made a copy of the code. It had Signal protocol inside, and they removed the requirement from to have a phone number to use Session, and the network of servers was more decentralized, obviously, and that was a good start. But then later, around 2021 or 2, I think, Session decided to remove Signal protocol, right? And they are on a defensive since then about this decision, right? So I think it was a very big mistake to remove Signal protocol without adapting it to the decentralized network design. The argument was that it's hard. Yes, it is hard. The hardest thing with Signal protocol is not decentralization, it's multi-device, right? So because you have to make some decisions around how, and we still didn't solve this problem for multi-device on SimpleX network, right? So Signal protocol obviously stands in the way of using the same user profile across multiple devices. Session decision resulted not in just removing Signal protocol. Unfortunately, it became literally the least secure end-to-end encryption implementation across the board. There is literally no other messenger with end-to-end encryption that has worse end-to-end encryption than Session has. You know, there will maybe many are happy people for me saying that, but that's just objective reality. It doesn't have forward secrecy. It doesn't have break and recovery. It doesn't have any pattern to this encryption. There is no key rotation at all. Messages are stored long-term, and the key used to encrypt these messages is easily accessible through the device. And also, unless you put a pin on your app, then the device can be easily, this encryption key can be easily accessed and cloned to another device. And whoever got temporary access to your device can, from this point forward, read your messages forever. We've been discussing that, and I don't know if they want to fix those problems or what's their plan. But I think at this point, saying to users that Session is secure is just gaslighting, unfortunately.
It'd be interesting to get you all in a room to maybe discuss.
Yeah, I would be happy. I would be happy to. I actually offered that. I'd be happy. I know all the arguments that Session has against SimpleX design, and the argument that SimpleX design is less decentralized than Session. It's an interesting comparison, and we can go into that. I have something to say on that as well. But I think the big difference with our approach to problems that we have is not to hide the head in the sand and to remain in denial about these problems. We listen to what users say. We make objective assessments about whether we think it's a problem worth solving or we want to live with that, and we acknowledge that and we talk about that, and then at some point we may solve it, right? We recently evolved from the design that didn't really protect user IP addresses from each other to the design that not only protects user IP addresses from each other, but that also prevents any of the network operator observing which IP address talks to which IP address. So that was a major change. It was a very complex change. We launched it with like 0 breakages to connections or any kind of negative consequences to the users. So currently, the design we have, it both protects your IP address from your contacts, and also it prevents network operators from seeing which IP address talks to which IP address. So they know which IP addresses connect to theirs. So like, for example, one of the criticism that, I don't know who invented this, SimpleX servers can see users' IP addresses, yes, so can Tor relays and VPN providers. It literally doesn't matter how you use the network. intranet, right? There will be some servers that will see your IP address. You can only choose which one will do it. So yes, if you connect to SimpleX servers directly without any overlay, like VPN or Tor or any other overlay network, then yes, the servers you connect to will see your IP address. That's true. But what's important that the servers will not be able to see which IP address connects to which IP address.
Got it. And so what would you say is the limitation in your guys' approach compared to the other two options?
I think the big limitation is complex. Obviously, this approach to decentralization creates lots of technical complexities, and that makes it harder to scale the network. We're currently right in the middle of process of scaling this. We did find a solution, obviously, how to scale it, but I would say it's way more complex than using a traditional approach when user has an identity on the server and server knows who the user is. This traditional network topology is much simpler to develop the code for, I would say, and it also makes it much easier to scale. So I think it's harder on us, better for the end users. I think that was fundamentally the trade-off that we bought into, like that will do harder work to make better value for the end users.
Got it. So before I touch on the encryption and security and kind of go into how you guys use the Signal protocol and all this stuff, I had two notes as we were talking here: scaling and different ways to use SimpleX. Because when I open SimpleX, I think I have the option to use just a regular, default operator. Please correct any terminology on my end. You can self-host something, I believe, as well. So if we can talk about scaling and then also the different ways to use SimpleX and kind of the trade-offs between them.
I think it's not very connected subjects, but let's start from how we use. So currently, if you just use the app without making any advanced configurations, then you will be using two different companies as network operators. One of those companies will be us, we provide some servers, and another company will be Flux, they also provide some servers. We have the same privacy policy. We have an agreement between each other, obviously, which obliges them to adhere to the same privacy policy as we do. And when users agree to conditions of use, they agree it with both of us. And that provides more privacy than if there was just one operator, right? This is objectively worse than having 100 different known or 10 different known operators who commit to the same terms. And that's the model of the network we work towards is when we build the commercial model into the network that will incentivize operators to offer their servers. And by incentivize, I don't mean minting some shit coins. No, I mean like community owners funding their channels in the same way they fund websites, and that provides revenues to operators. So we don't want to skew the balance, right? So that's something that we're working towards right now. So there will be some big announcements to that. So effectively, we want to be in a world when, without any advanced app configuration, by default, you're using tens or even hundreds of different known companies who contractually obliged to stick to the same privacy policy. That's the future. We're not there yet, right? We currently offer only two companies, and we're in conversation to add a third, which may happen rather soon. But that's objectively worse than having 10 or 100. Now, if you compare it with network designs like Tor or Session, on one hand, you have hundreds of nodes there, right? And traditional view is that this is the better model of decentralization. The problem is that you don't know who runs nodes, and your whole security model is based on the assumption that these nodes are run by different parties, right? But you don't know that. And second, they don't have any contractual obligations to you. They don't promise you any privacy terms. They don't promise you anything at all, absolutely. They can log IP addresses, they can log them, they can do whatever they want, right? So all the networks with anonymous operators in comparison to what we did has the downside, right? So multiple nodes can be run by the same party, and multiple nodes can cooperate and share data in order to determine and effectively de-anonymize user connections. They wouldn't violate anything. They would violate the spirit of the network, no doubt about that. But since when it stopped people who are commercially motivated? right? So like if there is a demand for Tor traffic data, and there is demand for Tor traffic data, there are suppliers of Tor traffic data or session traffic data, there is demand for that, then there will be supply, right? Like some operator nodes will be selling their traffic data for aggregation. That effectively undermines the model. And the argument is that a small share of nodes will be owned by malicious parsers. Yes, that's true. But statistically, if you choose the nodes randomly, like we published this calculation somewhere. So let's say even if 2-3% of nodes in a large decentralized network are controlled by one party, this party can't subvert the whole network. So when people think about Sybil attack, that Sybil attack is not possible unless there is a huge number of. But the problem is we're not talking about Sybil attack. We're talking about determining who talks to whom through the network. Because the purpose of Tor network or session network to hide this information, right? Because people don't connect to each other, they connect through intermediaries, and the purpose of the network is to protect those connections. But even if small number of nodes are run by the same party, then this guarantee no longer holds. Like after many random choices, you will be hitting multiple nodes controlled by the same party eventually, right? Just because you choose them randomly, statistical calculation is this. If you have 2% of nodes controlled by one party, you have to make something like 1,700 random choices to hit nodes of the same attack, which is not too many choices, right? Like you use the app for say half a year, and eventually you'll be hitting problematic connection paths. So again, that's answering the question how people use on decentralization model and what's the alternative, right? So many people use the app by their own servers, right? So we know about lots of like work groups or teams that run their own SimpleX servers and use their servers to connect to each other. The great thing about the design we did is that users decide which servers to use. Like when you use Tor, it's hard to make those decisions. When you use Session, it's impossible to make those decisions, right? Like the app decides for you. We give this control to the users, 100%. So users can configure the app or which operators to use and how to use them. And they can be their own servers. So users can, for example, use our servers to store messages in delivery and then use some low reliability servers as a proxy for connections, or vice versa. So they can use their own servers for delivery and our servers as proxies, and we've heard about all those combinations. So we give people configuration about which servers to use and how to use them in which role on the network. What we don't yet is we don't have currently the same level of configuration for custom servers as we have for preset operators. That's coming very soon. But nevertheless, lots of users use their own servers in combination with like servers that are pre-configured in the app.
I see. And I always forget to ask these questions early on because for me it's just obvious, but everything you guys do is open source, right?
100%, yes.
Yeah. Okay.
Yeah. No, I have been doing open source for a very long time, and I think it gives you much higher quality. It gives you much, like I was saying many years ago, long before we had ChatGPT 4 or Grok 4, that there will be very little benefit of having closed source code because we're moving to the world when advanced LLM can take your binary code and literally like reverse engineer it and write it. So by hiding your source code, you're only protecting it from small players who don't have large LLMs, and you're not protecting it from large players who have large LLMs at all. So there is very little benefit. So licensing works, right? So like if you license your code under, like for example, we license under AGPL v3, which allows people to use it, but it imposes the requirement on them to make code available to their users if they modify it, which provides both security and also protection from any kind of changes that users wouldn't know about. So yeah, so it's 100%. It's both the app code and mobile apps code and core of the app that does cryptography and messaging and service code. And we had quite a few situations when users were pointing out bugs in those code before the release, and we had quite a few important contributions to it. And I think literally 100% of people who are in the team were contributors who literally found the project, liked the project, did some contribution, then did some other contribution. Then we said, like, why you're not working with us 100% of time yet? So I think I see only upsides. I don't see any downsides to the code. The whole idea that if you don't close your code, you can't make a commercially viable business, is just wrong. It just means that you have to figure out a commercial model that's not based on the idea of hiding your code. And your competitive advantages should be not based on hiding your code, but should be based on something else. But we want the competition to exist. We are competing with such big networks that we absolutely cannot compete if we are the only developers. So we literally move into the point when developing alternatives apps will be easier, because again, obviously we move very fast, right? The protocol documentation a bit lags, so, and it's really hard. So we didn't do what Matrix did, for example, from the very beginning. Matrix, when Matrix development started, it started from a point, okay, let's make a protocol, let's make it public, let's create a committee that decides on the protocol evolution, right? And let's multiple people build multiple apps in a spirit of open source and transparency, etc., right? The problem is it's a dead end, right? Because you get product to some early adoption this way, right? You may even get faster early adoption because multiple developers develop, promote, etc., etc. But then you realize you need some fundamental protocol changes. And you have, let's say, 3 or 4 different apps. You now need to agree those changes. It's almost impossible. And the whole conversation about how we evolve it from V1 to V2, and then from V2 to V3 of the protocol becomes really, really, really hard. So we kind of want to do what happened with the web, more like when there was a moment in the web, in the history of the web, right, early, like before the 2000s, right, there were like 30 odd competing browsers. More than 30 startups that were competing with Netscape at the time. Nobody knows their names, right? So Netscape took it upon themselves. They said, all right, we have a web protocol. That's great. That's not suitable for a widely used product. Let's evolve it. Netscape single-handedly added SSL, which is transport encryption, right? TLS now. Then they added cookies. People think cookie is a bad thing, but cookie is abused to be a bad thing, but without cookie, a website can't function, right? The fact that you can log into Facebook depends on cookies, right? It wouldn't be possible. Anybody would be able to log into your account, right? If there were no cookies, right? The cookie allows Facebook to recognize you. And then they added JavaScript, right? So fundamentally, Netscape in a matter of a couple of years and many millions of dollars, and losing completely compatibility with the rest of the browser, they created a new product based on the web, and it became a mass market product because of that. So we see currently the protocol we have, Mastodon has, Matrix has, is kind of version 1, right? It has to evolve quite rapidly to version 3 with much more funding, but with a absolutely ruthless focus on doing what users need and not trying to have competition across development teams.
Yeah, so on that note, let's talk a little bit about the encryption that you guys use and the security model. I want to start by Signal. So why did you guys pick the Signal protocol? And are there any modifications that you make to it?
I think we've been super lucky. When we designed the Signal, it's almost an anecdote. I'll tell you that when we designed the network design, it was before it was widely used. We just developed some early stage prototype of conversations, and there was serial code. It was all in terminal. There was no user interface, etc., etc. And then I asked Mozilla gave me a grant to my previous open source project. Library for Validate. It's a very successful library, by the way. So I just asked them, can they maybe recommend me someone to look at what I did, because I don't understand cryptography much. It was like early 2022. And they gave me somebody who eventually became our advisor on protocols. He looked at it and he said, I don't want to help you. I said, why? He was very reticent to give me any feedback. I said, look, man, I have a tough skin. You can tell me how it is. I don't need nice words. I just need you to tell me what it is, and maybe we can make it better. So he said, all right, what you've done is a complete shit. You have a good seed of the idea there, which is message routing. You invented a fantastic message routing protocol like nothing I've seen before, and your cryptography is a complete shit, and nobody does it like that anymore. That was early 2021. Right. I said, all right, how everybody does it? So everybody uses Signal. Signal is state-of-the-art end-to-end encryption. Just use Signal and stop inventing shit. Don't invent stuff you know nothing about. And then he said, and also he pointed out some other possible attack vectors and everything. I think, and he eventually became our advisor. So I think what he was surprised is that we actually did all that he suggested. We switched to Signal protocol in a matter of like less than 2 months, and we fixed all the vulnerabilities. So like when we released SimpleX protocols version 1, it was a complete full rewrite of the whole, like it retained the engine for message passing, and it retained some semantics, but fundamentally we changed more than we kept in the core of the network design, addressing everything. And that's why Signal, simply because it provides 3 very important qualities for what is end-to-end encryption. So one is forward secrecy. What forward secrecy is? It means that if somebody somehow manages to crack encryption of a single message, maybe via brute force, or maybe they obtained the state of your design from some date and they have the key that was used to encrypt this particular message, it wouldn't allow them to decrypt past messages. I find this terminology very counterintuitive for normal people, because when we talk about forward secrecy, we're actually talking about the security of past messages from the future compromises. Maybe that's why it's forward secrecy, but it's about security of your past, right?
Yeah, it's historical.
From future attacks. That's what forward secrecy is. And forward secrecy is very widely used. Like every modern browser uses forward secrecy. So literally every single person on the planet, one way or another, uses forward secrecy, and it's like a staples of encryption. So forward secrecy is exceptionally important, because otherwise your whole correspondence, your whole history of messages becomes compromised from a compromise of a single message. But Signal doesn't stop there. Signal invented a different attack vector. He said, all right, because very common attack is a break-in, right? When attacker gets temporary access to your device. Break-in attacks are easier than compromising your device permanently, because to compromise your device permanently, you have to install some software on it, and there may be some protections from installing software, etc., right? So although, and then there may be some network connectivity issues. And what Signal protocol does is regularly rotates encryption keys in such a way that if your device was compromised, then your future messages will become protected after some time. And this quality is called post-compromise security, or break-in recovery. I prefer the term break-in recovery because it's a process, right? It's something that protocol proactively does in order to recover the security after the compromise and after the specific type of the compromise, which is break-in. Because obviously, like, for example, I've heard the argument from many people that we don't care about protection from long-term key compromise, because if your long-term key compromised, everything is compromised. But this assumes that attacker retains access to a compromised device, which is a harder attack, right? And there is a separate class of attack called break-in for a reason, because, and in many cases, break-ins are easier to execute than terminal compromise, right? So like this post-compromise security of Signal and break-in recovery in Signal protects, recovers the security after compromise happened. And that's actually exactly why running multiple devices is hard with Signal, because even if you make a copy of your database, from the point of view of encryption algorithm, it's a compromise, right? And if you try to run this copy in parallel on another device, one of them will stop working because it will be seen as a compromised copy. There are solutions, right? For example, Signal Up has a very elegant and simple solution with its own downsides, but it works literally making every conversation a group, right? When you connect with somebody, then each your device is effectively a separate participant in this group, and there is break-in recovery between devices, but they all kind of send messages to all participants in a small group. So like you say, you have 3 devices, I have 2 devices, we will have like 5 participants in this small group that from the user experience will look like their conversation, but from the protocol design point of view, it's a group. So that's what Signal does. That's what probably we will do as well. The downsides of this approach, obviously, is that you can see which device was used to send the message. There are various attacks on this, so there are some downsides. Okay, so, and the third thing about Signal, also very important, called non-repudiation. Repudiation. Non-repudiation is ability to prove who sent the message, and repudiation is lack of such ability, which means that if you send me a message on my device, then I cannot prove to a third party that this message came from you. I can prove it to myself, but I can prove it to myself only because I know that I didn't send the message. But I have the same encryption key, and I could have encrypted that as well. So I do not have a cryptographic proof to another party that you have sent the message, and I technically can fake your messages on my device. So I can construct a proof that will look on my device as if you sent the message, and it will be indistinguishable from if you in fact did send the message, right? If you didn't send the message, you can deny it, and I can't prove it cryptographically. Now, many people say, okay, this is not an important call. Let's say this was never successfully used in court. This defense was never tried. I find this all moot point. The whole kind of concept of deniability was invented less than 20 years ago, right? If you look like off the record messaging, this whole concept was published as a paper before 2010. Signal was the first messaging application that adopted this approach in Signal protocol, and it wasn't even mass market up until when 2020, probably 2017. Even now, Signal is used by maybe 2%, less than 2% of the population, right? So the fact that it was never successfully used in court is irrelevant because court precedents sometimes takes many decades to evolve, right? But the problem is, if you're a high-profile person, right? Imagine you're a CEO of a large company that runs multi-billion contracts. So somebody will try to abuse the communication with you. Somebody will be like trying to fake messages with you, or somebody can use the messages you sent in confidence against you. So, or fake messages against you. So deniability provides an interesting defense line in the court of law. I think it should be used by some people sooner or later, right? Because if you in fact didn't send the message, then the other party will not be able to prove it. Today, the common practice today is that people accept screenshots, people accept device copies, people don't go into high-profile expertise to establish if deniability is important quality or not. Technology usually is many decades ahead of law and legal precedents. I see deniability as an important concept, right? SimpleX network provides full stack deniability, so both on server levels and on client level. And I think that there will be some profile cases when this defense will be successfully used.
Yeah, maybe it'll be some of the people in security positions in the U.S. administration.
For example, for example,
like
yeah.
a journalist claims to be in a group with all of them, they could say, well,
Exactly.
we never sent those messages. It's not real.
Exactly.
Yeah.
For example, right? So again, I'm not advocating that people should lie in court, but nobody should lie in court, right? You should say the truth. But you understand that your message can be taken out of context, right? And what you say in context can be interpreted and misconstrued to mean exactly opposite to what you have said within the context, right? And if that's what is used against you, you would be right to say, I didn't send this message, because, yeah, you may have sent exactly those words, but the meaning of those words was completely different, right? And they cannot really, and then you have a choice. Either you can say, okay, this is the whole transcript, but this transcript can reveal other sensitive information, or you may take a defense line, okay, this is not what I said. So I would say that there should be high-profile cases that would rely on this technical parameters of Signal protocol, and it's also a very important parameter. So anyway, so it's a long kind of journey around how Signal protocol is different from everything else. There is nothing else comparable today which would combine all three qualities I just listed and not be Signal protocol, right? And nobody so far managed to improve on top of that, say, okay, we have this three quality, but then something else as well. There's literally no alternative today. If you want to have a secure end-to-end encryption, you will be using Signal protocol. It's a huge credit to inventors of it, Moxie, Morenspike, and I think Trevor Perrin was the other guy. So I think that's their huge contribution to technology and to encryption. And my today understanding of cryptography obviously is very different from early 2022. We understand cryptography really well. We amended Signal protocol with post-quantum encryption before Signal did it. Signal did it just recently, but we did it on the same principles, right? So we created some very strong cryptography around short links that we recently introduced. So we now understand how we should design cryptographic schemes, and every time we get through, like we had 2 security audits, we'll have security audit next year again. So I think we get so far rather encouraging alignment with much higher cryptography experts about us doing a good job when it comes to cryptography.
Now, one thing, you mentioned matrix earlier, a really big criticism that I have actually, and I see a lot online, is that the home server sees a lot of metadata, not just, there is end-to-end encryption if you enable it in matrix, but there's still a lot of other data there. So what does a relay see in SimpleX? What kind of metadata protection is built in when someone's messaging on it?
I think it's wrong to compare Matrix and SimpleX
No,
message
I'm
passing
not.
directly, because
Yeah.
Matrix server provides you a place to host your conversation, and in particular, if your conversation is public, then you don't want to hide content. The problem is that in Matrix design, you have the same server that's used as a transport and as a hosting for the conversation, if you understand what I mean, right? You connect to the server, it delivers your messages, but it also hosts the actual messages, right? And that's the problem, because in this case, I'll get to the question. I'm just trying to explain what's the real problem. The real problem is not that the server in Matrix sees some metadata, but it's the same server that also sees the message content. So it not only sees who sends messages, and it not only sees what messages are, it can connect sender identities with messages. And that's where the fundamental problem happens, right? Because if somebody says something problematic, but nobody knows who they are, it's not a problem. And vice versa, right? If somebody sends messages, but nobody knows what they sent, again, it's not much of a problem, right? Something is being sent. But when you can connect identity to content, that's when the personal security gets compromised, right? So with our current messaging relay, they obviously don't see the content, they don't see the conversations, and they, of course, see some metadata. I think protecting metadata is just an oxymoron, frankly, because you cannot protect it if you use metadata, right? You have to use some metadata to deliver messages, and what you want is to minimize the metadata, not protect, but to minimize the metadata that you use, and minimize the metadata that you can observe, and minimize the metadata that you can record. So if you're talking about metadata and communication, we're talking about three different things, right? Metadata you can observe, that's one thing. Metadata that you actually need to transmit messages, right? You need some metadata, and metadata that you record long term, and there can be three different things, right? So if you connect to messaging relay, they obviously can observe your IP addresses inevitably. They don't record this information. We put it in our privacy policy. We don't have any need to record those addresses, so we don't record those addresses, but technically they can observe the IP addresses. They can also observe connection times, right? They know when you connect to the server, and they can see when each address connects to the server. Again, they don't use this metadata and they don't record this metadata, but that's an observable metadata. And the same will be true for any kind of network. Tor relays can observe the same, session relays, VPN providers. It's all kind of universal, right? What they do use, what they can't observe, though, is very important. They cannot observe the message size. Because SimpleX network is probably, I think it's the only network that uses fixed packet size of a rather large size in comparison. Catch also uses fixed packet size, slightly smaller. So we use, every single message you send is 16 kilobyte. It's padded to 16 kilobyte. Doesn't matter how large it is. It can be a long text, which it can be like image preview that takes 16 kilobytes, or it can be just a thumbs up reaction. What network will observe will be 16 kilobyte traffic, which is purposely wasteful. And obviously you don't need 16 kilobyte traffic to send thumbs up reaction, right? You need several bytes, maybe 100 bytes. But this design prevents correlation by traffic across the network, right? Because if you send messages of variable size, then it becomes very easy to determine who talks to whom simply by seeing how those sizes correlate on different parts of the network, right? And if every single message has the same size, then network observers can't establish who talks to whom. And servers can't observe it as well because they don't know their real message size. They only see the fixed block size of 16 kilobytes. They obviously have like destination address, but again, destination address is not the user, it's the messaging queue, and the user can have tens of thousands of those message queues, and they wouldn't, the server that sends they wouldn't necessarily know how queues correlate to users. But the whole idea is like every time you send a message, it goes through two servers, right? And the first server knows your IP address and it knows the destination server, but it wouldn't know the destination address on that server. So cumulatively, you send to this other server 100 messages, but they wouldn't know to how many contacts. It can be 100 messages to one contact, or it can be 100 messages to 100 contacts. The first server wouldn't know not which contacts nor how many. And the destination server would see the addresses, destination addresses. It would know which queues to put the messages in, but it wouldn't see which IP address sent them. And they wouldn't know even, like, again, is it, let's say, if messages arrive to 100 addresses, do they arrive from one user or do they arrive from 100 different users? They wouldn't know that. And the protocol is designed in a way that they simply can't share this information with each other. So they don't observe it, because there is an end-to-end encryption tunnel, not just between the users, but between user and the destination server. There's a separate end-to-end encryption, like not end-to-end, but let's say user to destination, there's a separate encryption tunnel. It's kind of how onion routing is designed, when you wrap encryption layers one on top of each other to protect information from intermediary relays. So in a way, SimpleX network functions very similar to how mixed network function. It's just low latency mixed network, and the difference is it's very tailored to the problem of transmitting messages, right? It's very specialized to this particular need, rather than being a generic. And it's very different from Tor, because Tor establishes connections, right? So even if you connect via Tor, there will be a persistent circuit built via Tor, and everything you send via the circuit can be attributed to you as a user. When you send your messages to the destination, there is no persistent circuit. There is just packet level, like encryption and security, rather than circuit level, like with Tor.
If anyone is listening and they don't like the idea of their IP address being collected, I'm sure we can recommend people use VPNs or Tor when they're using SimpleX.
100%, yeah. Well, we're not collecting them. What I'm saying is that an IP address is theoretically observable, but that would be the same whichever network you use. If you use VPN, your VPN provider may be observing your IP address as well and may be collecting them. And if you use Tor, then your entry node on Tor is also able to observe your IP address and also collect your IP address. So the choice that people should be making, I think it's very dangerous for people to have an illusion that they can use intranet in a way when nobody observes their IP address, because there will be always that somebody. They have a choice of who this somebody is, right? And they have to make the correct choice there. So, and yes, you're absolutely right. So in many cases, by combining multiple parties, you may increase your security, right? But you can also reduce your security by combining multiple parties.
Right. So I guess my question, and what some people might be wondering, is there a reason you haven't opted for built-in IP protection that would change the party away from, I guess, a relay? I know you already explained it to people, but I know some messengers might opt to do like a Tor onion routing, but then I assume that's just going to add a huge amount of complexity.
No, it wouldn't add complexity. I think Tor is, I don't want to couple the message passing network design to transport protection network design. We're currently allowed to use the app with SOX proxies, and SOX proxy allows to abstract this transport network. So you can use, if you want to use Tor, you can use Tor. If you want to use I2P, you can use I2P, right? Or if you want to use some other design that we don't know about, you can potentially also use it, or you can use your own SOX proxies. We just think these problems should be, kept separate, and by putting both protections in one app, we're not increasing the security, we are reducing it, right? Because there is no bulletproof things, right? Tor protection is not bulletproof. So like if we wanted optics and look like, we don't want to look like the most secure message, we want to provide actual real security. And while optics of embedding Tor may look good for some people, reality is bad, because it means that now we're responsible for shipping Tor code. Right? Now we're responsible for security updates on Tor code. Now they depend on us to provide integrity of Tor code. To me, as a user, it all sounds like a horrible deal, right? Because if I want to trust Tor, I want to get Tor code from Tor developers, not from SimpleX developers, right? So they provide me the code, because in this case, that provides additional security. Even if I do make some mistake, then I have Tor to protect me, right? But that all kind of predicated on the fact that I get Tor code from Tor developers and not from, why would I, like, I'm putting myself in the shoes of a user, why would I trust me to ship me Tor? I don't develop Tor, like, why should I embed it in the app? It looks like it looks good for non-technical people, but reality is, it's bad. And for even non-technical users, the time it takes to start using SimpleX via Tor on Android device is exactly 1 minute. You go to the App Store or Play Store or F-Droid, you download Orbit app, you press start, then you go to, like, it's literally like, it's a 1 minute instruction. And if people find it technically complex, they honestly shouldn't use Tor at all. That's my strong opinion, because Tor has some limitations to its threat model. You have to understand the limitations to the threat model, right? If you think that this kind of install a second app is technically complex, you'll make so many mistakes with your AT security that Tor is not going to help you. It's only going to hurt. So I generally think that by embedding Tor, we're doing a bad service to our users in all means.
Got it. And then, let's pivot more into the usability side of things, I guess, to go away from the technical side. So what are kind of the usability challenges right now? Because it's a complex network and it's a lot of stuff going on. So where do you feel like that's kind of increased complexity on the usability front?
We're still in the world when many new users who don't come via the introduction find it difficult to connect to other people, because obviously you can't enter the phone number as they used to. You can't search for users in the app. You need to somehow search them outside of the app. And we can see that if people come via the introduction of somebody who already uses SimpleX, then normally they successfully get onboarded, they start using it, and they understand how to use it. But if they simply download the app from Play Store or from App Store, then the most common question we get in support contact is embedded into the app so they can connect to us. And one of the most common, not the most, but one of the most common questions is, okay, how do I connect to people? And we've iterated this user experience for new users many times, and we're still looking for better way to explain to the new users that, okay, you have to create the link, you have to pass it via some other channel, just because that provides security from us. And then you have this, somebody else have to use this link in the app. And even though we recently improved usability of links by a lot, right? Like we had like huge 500 character links, which everybody considered malware. Not everybody, but everybody non-technical consider them malware, right? They look at it as, oh, it looks scary, I'm not going to use it. So now they're short and nice, and if you tap it, you see the name of the person you connect to before you connect, and you can send message together with, like, it's really, really nice compared with what it was, right? So still it remains a challenge. That's literally a simple thing, how people connect. That's a basic thing, and we still didn't figure it out after 4 years. That's like, it's embarrassing, frankly. But it's a complex, like that's whole kind of fundamental innovation that we created a new network topology when users don't have identifiers, which means that you can't find users. You don't even know how many users are there on the network. That obviously creates a UX challenge that we didn't crack yet. That's probably remains the main thing. So, and the second most important thing is what is the complex development is just making large groups work, because the current groups on SimpleX platform is a client-side broadcast, right? It's like mailing list under the hood. You want to send a message to the group, you have to send it to each member in the group. It all happens automatically. It looks like the usual group, but it creates lots of traffic. It also means that messages may reach some users, but not reach some other users. And then they see messages in different order on their devices, and they can also see replies to messages they've never seen. And that just comes with the territory. So if the group doesn't have a single source of truth that is reliable and always online, then different people in the group are likely to see somewhat divergent histories in the conversation. So we're working on that. That's technically complex development. So we are going to introduce what we call chat relays now. So effectively a special kind of client that would probably act conceptually similar to Matrix server, but unlike Matrix server, it will be based on client technology, and you'll never connect to it directly. You would still connect to it via SimpleX messaging network, which means that even though this chat relay can see public conversations, there will be end-to-end encrypted conversations as well via chat relays. But even though it can see public conversations, it wouldn't be able to know which are the users, because there are no direct connections between the users and chat relays. So like if you use Matrix server, you have to connect to it directly via the internet. Yeah, you can use Tor or whatnot, but you still have to connect to the server via the internet. In case of chat relays that we're developing now, you will be connecting to them as if they were your contacts, meaning via 2 servers messaging servers. So there is no direct connections. They don't see your traffic. They don't see your IP address. They don't know where you are on the network. So that will address one big usability challenge with the groups. But we can still see the interest of groups grow. And they recently made, we have a small directory of groups, approaching 500 groups that people created on SimpleX networks. Some of them have more than a couple thousand people. And this directory is since recently available as a web page. And that kind of makes it much more accessible. It's easier to search for them on the web page. We offer a chatbot that allows to use this directory, but it's also available as a web page since not so long ago.
Got it. And so really quick one, is message delivery about the same speed as what people might expect from their typical app?
Normally, yes. Normally, latency is determined by the network conditions. And yes, people with slow network connection find it slower simply because of fixed block size. So if your network is really bad, you will see it as slower than most other apps, because when other apps maybe send in like 100 bytes of data, you have to send 16 kilobytes of data, right? And if your network is really slow, then there will be some difference, right? But if your network is reasonably fast, which is like modern 4G or 5G networks, mobiles or Wi-Fi, then you would not see noticeable delays in message delivery. And like, for example, when I send message from my desktop client, I usually see second tick, meaning that it's delivered to another device, and I got the response confirming that it was delivered in under like 300 milliseconds many times, like certainly under 1 second. So yeah, so it's on par with more usable messaging apps.
Yeah, and on this note, Facebook has outages, and Signal has had a couple outages, normally when they get a huge influx of users. How does that work with your model? Is it possible for SimpleX to be down, if that makes sense?
100%, yeah. So, I mean, we don't, the whole network can't go down because it's fragmented, right? And each connection depends on some server. And right now, if this server is down, then some of your contacts will be down. Not all of your contacts. So the SimpleX as a whole can't be down because we don't control all servers. Nobody controls all servers, right? But because each conversation depends on just a specific, in each way, right? So you can be in a condition when you can receive messages but can't send, or the other way around, to a particular contact. You can send but can't receive, right? So because one way you will be using one server, another way you will be using another server, that they are both down is very unlikely. We have a status page that shows the historic downtimes for all servers. They are well over 99%. Normally it's like 99.98% for many servers, but we do have maintenance windows. We recently migrated to new storage approach that reduces maintenance windows from minutes to seconds, so that improves deliverability, but the migration itself was painful. So yes, so effectively people experience some downtime with specific contacts when this particular server is restarted. And our answer to that going forward is that each contact should use multiple servers, not just one server to send, another to reply, but you send, let's say you send each message through 3 servers, and each server lives with different operator in a different data center in a different country. The probability of all of them going down together is like literally 0. Rather than having each connection, each contact on one company, you will have it dependent on 3 companies, and for it to stop working, they all 3 should stop working, which almost never happens. So we don't want to be in a situation when Facebook is down, right? So like right now, a segment of the network can be down, but we want to move to the design when even some part of the transport network going down will remain completely unnoticeable by the end users.
Got it. And then how about multi-device sync? How does that work with SimpleX?
It doesn't.
Okay.
No, we have a technology that allows to use mobile app from desktop interface as a remote access. But that requires that both devices are on the same network right now, meaning both mobile and desktop. And it's effectively just a convenience feature that allows you to type messages from bigger screen and bigger keyboard through the profile that you have on mobile device. It doesn't fundamentally create any synchronization problems or anything. You just use it as a remote connection to mobile device when you're using the desktop. That works for some users.
Just to be clear, you can also just not use a mobile device and make the desktop client your main device as well.
Correct, yes.
Okay.
You can, yes. But then you wouldn't be able to use this profile anywhere else, right?
So you have to pick.
Yeah. So, for example, for our support, we do an interesting thing here. So we run our support client. Like support is the profile that users connect to through the app, which says Ask SimpleX Team in the app, right? So it's a client that runs in the cloud online 24/7, and whoever will be replying to those support requests will be connecting to this client in the cloud via the same remote connection from desktop. We have it documented somewhere. So we effectively allow, like, we have an approach that allows multiple people use the same profile and reply to people in turns. But what many people want, like, I have this profile on two mobiles or on mobile and desktop, and I can use them both together or in any order, and I don't need to do anything to connect them. That doesn't work yet. So we consider several approaches, and most likely we'll go with somewhat strengthened approach of Signal. What Signal did is rather simple, as I explained earlier, right? So they just put all devices in a conversation into a group under the hood, right? So what for users looks like conversation between two people is effectively a group between 5 devices, let's say, or 4 devices, right? That's a viable approach that has downsides, such as you can see which message is sent by which device. That also has some attack vectors. So far, it looks the most reasonable and the most viable compromise for most people. What we want to avoid, and what's possible to avoid, is the attack vectors that Signal introduced, which allows to add device unnoticeably to the end users, right? So like Signal relies on PIN verification when adding another new device, and that's effectively depends on trust to Signal, which I think is a bit thin generally. If your security depends on trust to provider, then it's not very good security. So our whole philosophy is that your security should depend on cryptography and not on and open source code, and not on trust to a particular provider. There is an interesting paper published. I can send you the link if you're interested. There is a good paper that cryptographers published about this vulnerability of Signal around 2021. I think it's really important that they address it, because it effectively allows any attacker that managed to somehow compromise part of Signal infrastructure to add a device to any conversation. And the problem is users don't get notification when the device is added. Mm-hmm. And they can see it in the list of devices, but you have to proactively look for it to see it.
Got it.
And the way the paper describes it, it's rather worrying attack vector that I think Signal should address. But Signal was good at addressing various vulnerability community was pointing out recently. It was not very good maybe a couple of years ago, but I think nowadays Signal is a bit more responsive to community criticism. And to me, that multi-device vulnerability remains the biggest downside of Signal security model. And the solution is really simple. Just let users scan the security code, even if you add another mobile, right? So effectively make trust between devices established on the client level without Signal being involved, right? So anyway, so if you go this way, then we'll obviously do it like this, and it will be secure. And the only downside that cannot be addressed is that your contacts now can see which device you're using. That's the main downside of this Signal model, right? Which may be okay for trusted contacts, but they may be not so good for participating in public groups, right? Obviously, the future chat relays make it less important, because only chat relays now can see which device you use, but other members wouldn't be able to see it. So I think once we move to the new model for public groups, this Signal approach to multi-device becomes acceptable from security point of view.
Great. And then how about, we're almost done with the usability, and then it's just like business, finances, legal stuff. But for battery impact, is there a battery impact for having to do background sync for things like notifications on mobile devices? Is that different from something like Signal?
I think we reduced battery usage by a lot in the recent releases. I think we did something rather stupid on Android early on by never releasing awake locks, and we recently realized that. And I think the current Android releases do like much better and better usage than like even 3 months, maybe 4 months. When did we do it? Several months ago. Decentralization adds to battery usage without question, but I think 90% of the damage was self-inflicted through engineering mistakes. We copied our approach from NTFI app in like NTFI app that is effectively used as a broker for push notification delivery, and SimpleX app does the same on Android devices, right? So we copied our approach from them, And then they fixed this bug like about 1 year later, and we didn't fix this bug. So yeah, so that was the that was the story. And then recently we discovered that again it's embarrassing, but here it is. So right now the usage, I think most users right now see usage as acceptable. It would not be exactly the same as Signal. You have larger block size, but everything has costs, right? You have higher security guarantees, you have better decentralization. But I think fundamentally the biggest usage comes from group decentralization, and once we move large groups to chat relays, the better usage will be on par with Signal.
Okay. And then do you do background sync on iOS, or is background sync only on Android?
We do background sync, but iOS is very restrictive in how you allow
Is it
to.
just we will periodically sync in the background?
It's effectively only works if you use the app a lot. On iOS, we use push notifications using Apple push servers. So it's completely separate part of the network that unfortunately cannot be decentralized with Apple model. But that's the only way for iOS to provide push notifications. So we have a special service that we host. Only we can host it because it has application keys on it that can push notifications when it gets notified about messages existence. It's highly secure approach, obviously. The notification server doesn't see not just messages, all the notification server sees is end-to-end encrypted metadata. Not just the message, but the metadata itself is also end-to-end encrypted.
And that's what you use on Android, but not on iOS.
That's what we use on iOS, but not on Android. For iOS, we use push notifications using Apple servers. On Android,
but your thing you use on Android.
No, we don't. Sorry, Android just runs background servers in the same way as it's not background refresh. No, we use the same. We use effectively we push messages in the same way as NTFI, like the unified push system, right?
Yeah,
NTFI
you guys
right?
use unified push, but then
we don't use unified push, but we use the same technological approach as unified push. And effectively, SimpleX messaging servers work as push servers. You don't have to poll messages. That's not how it works. When you message, you remain open connection. This connection can be maintained as open even when the app is sleeping. And if the message arrives, the server pushes it to this open connection, and the app then wakes up and shows you a notification. That's how it works on Android. So that's the same approach pretty much as with NTFI app.
Got it. Pivoting over to the business and sustainability. So I always like to ask about funding models. I've read some of your blogs. They're pretty spicy. And I don't know if I'm on the same page, but I still want to hear kind of
which one do you mean?
I think your takes on VC funding. I'm not fully on the same page as you are,
right.
But I'm it's an open podcast. We're open to different opinions here. So I'd love to hear kind of your guys' funding model, your views on it, and kind of the pros and cons between your guys' approach and other organizations.
I think the problem with investment is not who makes the investment, but what is being surrendered in exchange of investment. Like every investment deal is about two things. It's economics and control. And many inexperienced business people, they care about economics of investment, is how much profit you share, but they don't care that much about control. And investors like control. They like put some control provisions into the investment agreements. They give them the escape hatch if the business goes in the direction they disagree with, that allows them to replace executives, etc., etc. And that's what's dangerous for the integrity of the mission. And when people criticize VC investment, they effectively criticize not the economics of the VC investment, they criticize control of the VC investment. And many people believe that control is inseparable from investment, but that's just not true. The world of small early stage business investment has moved on dramatically from this control-centered investment model, simply because there were lots of successful entrepreneurs that have proven their investors that by doing things investors disagree with, they're making those investors more money. So for example, if you look at like Snapchat page, like literally like 99% VCs who have seen Snapchat page about deleting messages after they were sent, they said this is the stupidest idea we've ever seen. And so like, or Airbnb, or many hugely successful startups had very kind of and when whoever agrees to invest this idea, they understand that they really would not be able to meaningfully contribute to running this business without disrupting founders' visions. So the world of investment is hugely split between investors who do want control investors who don't. So when we were raising money in 2023, I was lucky enough to have Jack Dorsey offering this investment and some VC fund and others, but there is literally zero control provisions there. They don't have board seat. They don't have even remotely close to control and share. Like, it's really a small stake. And all they have is information rights, literally. And again, when I say financial rights, I mean information rights. I mean like financial information. We don't have to disclose corporate secrets. We can have a Chinese wall. We don't need to disclose who are kind of partners or contractors or employees. So they literally cannot participate in running the business in any way. But they offer a huge resource of advice, they offer a huge resource of support, they offer a huge resource for introductions, and you get, you not just get money to build a business, you get free advisors as well, which is fantastic, right? So I think when people say that VC investment universally bad, they're really talking about bad decisions that founders have made when they surrendered control early on to wrong investors who they're not necessarily strategically aligned with. At the same year when we raised money in 2023, we had 2 more term sheets. We could have raised like 3 times more money than we raised. And they both wanted control, and they said no to them both, even though economically they were very attractive. That's if we're talking about investment. But investment doesn't really create financial model for the business, right? So investment literally gives you money to do what, right? You can like, why investors? Investors invest in your ability to figure out how to make money eventually. And at this point, we have a viable. Our early theory about how to make money was traditional, we should use premium features. The problem with premium features is that people don't like them, and when they are universally introduced, it gets into like the product gets enshittified, right? The product starts getting optimized in order to sell those premium. How do you sell premium features? You get experience of everybody else first. So like that's what's happening with Telegram. Right, so unless you're a premium user, you get some progressively worse experience, and that's the only way to drive the revenue up is to make your experience worse. So at this point, I think that the commercial model we're going to build is not going to be based on premium features for the end users. We may offer some badges, we may offer some tokens, but that's not the core. That's not the core of our strategy. The core strategy is, again, we're going back to the principle of open web. How open web got commercialized. Right? It created a platform for people to build businesses and communities, and those communities are effectively and businesses are paying customers of the web. You don't pay to use the web, right? You don't pay for the browser, you don't pay for accessing the website. Some websites try to charge you for access, but that's their own decisions, right? But fundamentally, the web is free to access for everybody. But it's not free to host. If you want to host a website, you have to pay some money. What you get in return, you get 100% control of technology you use, you get 100% control of your audience, you get 100% control of your content. You don't surrender IP ownership in any way or shape or form. You have 100% control and ownership. That's a classic, what's called B2B2C model. So we as a business want to see our customers, other businesses or non-commercial communities that use the network to host content, to host communities, to engage those communities, and they will be their customers. My view is very simple. These communities should somehow cover the hosting costs in a way that creates profit for hosting operators. How will it cover the costs? Maybe the community is created by somebody who has some spare cash and want to spend it, right? Or maybe the members of community will donate. So we run some estimate, unit economics work. So estimate is very simple. So if community has, say, 10,000 members and hosts, say, 10 gigabytes of file, the price for this community on SimpleX network will be something around $5 to $7 a month. That will provide very healthy profit margins for network operators, privacy to community owners. How they cover this $5 to $7 a month, I honestly don't care. But they get an exchange much more than they get for effectively for a price of website, or maybe slightly more than website. But with website, you don't get technology, right? You get technology and the hosting, and that's all in the ballpark of the website. But you don't have to develop messaging, you don't have to move files around as you described. It just works out of the box, right? So that's the model they're going for. When communities effectively cover the costs of the network, and the end users use, some of the end users may donate to their communities, and that will cover their costs, right? So how they, or maybe it's community is run by the business and it's marketing expense for them. It shouldn't be. It's like in the same way as web browser developers and web service developers don't care how each website does their business and how they what source of money they use to cover their costs, right? Each website has their own commercial model, but all web hosts and companies care about that they pay their bills, right? And they're rather small bills. We're talking about, if it's a small site, we're talking about several dollars a month. If it's a large size, it can be substantial. So the good thing about this model compared with premium model is rather uniform, right? Each user on their own, and you can't get too much money from a user. But communities usually follow the power law distribution, right? It's like every healthy network, you get 80% of traffic created by 20% of communities. 80% of traffic is created by 20% of groups, right? So it means that you can make the rest 80% of group free, and you only lose 20% of revenue. So you charge the heavy users, you get free for everybody else, and that kind of creates profits for everybody and sustainability for everybody without asking them to surrender any intellectual property right, without asking them to accept the risks that they can be deplatformed, because each community can also use multiple operators. Even if one of them decides to deplatform, they will not, the end users wouldn't even notice that.
Got it. And then if we pivot to kind of the legal side of things, so you guys are legally based in the UK, right?
Correct, yes.
So with the, I'm sure you get this a lot, and I'm sure people are asking, I'm doing a lot of coverage as well on the channel about UK's attacks on encryption, what they're doing against Apple, ADP, age verification, all of this stuff. Does that impact you guys at all? How does that impact what you're doing, if at all?
I don't think it impacts us in any way. We are legally, we have very good legal advice from top tier firms. We did it early on, and we did analysis of all the applicable legislation. So we are legally in a category of web browser developers rather than as server providers. So we do not, like, the part of the business that provides software is not really providing any service. And the fact that users can use our servers today is very temporary and incidental, and we really cannot conflate these two, right? So, like, can you oblige under the existing legislation web browsers developers to undermine encryption in the web browser? The answer is no. There is no legislation for that. Not in the UK, nowhere else in the world.
Yeah, what about, because I'm seeing definitely, this is early on and it's very preliminary. It's just a concern that people have, but you see cases like the Tornado Cache developers where potentially the development of software, even if other people do something malicious with it, could still jeopardize the people who develop the software, if this makes sense. Are you guys concerned about a situation where you can be held liable for what someone else even does with your code?
I think what matters is the intent. We actively develop features that prevent criminal usage, right? We actively remove illegal content from our servers. We actively do a lot to prevent such usages. And I honestly think that what happened with Tornado Cache developers is really bad, and we should all be against that. But I think Tornado Cache was positioned really as something that would facilitate crime, and nobody was particularly shy about it. And we see what we do as a technology that protects people from crime. Criminals can use any technology, right? You can buy a car and start killing people, or you can buy a table knife and start killing people. Now, they're discussing in the UK that you should provide identity to buy kitchen knives now, right? So criminals can use anything. That's the problem, right? But if technology is purposefully developed to enable crime and it's not doing anything to prevent criminal usages at all, then the question of neutrality is being raised. I disagree with. I think technology should be seen as neutral regardless, right? My personal view. But I'm just like, also, while it's concerning to see that creators of technology are being prosecuted for actions of other people, and I don't think it should happen at all, I think we take a rather different stance than neutral, and our focus is to create technology that protects people from crime, the fact that you cannot reach out to the end. For example, the common subject, and this was being used in a lobbying of child control legislation in Europe, is that children are being exploited, right? But they're exploited by design. The networks where the children are exploited are designed in a way that children are reachable by anybody. And there is an open criminal case against Meta in multiple US states. It's a fascinating read if you look at this kind of witness statements and evidence materials about how Facebook and Meta technology knowingly enabled traffic of children to child abusers because it creates engagement in the network. It's horrendous. I think technology should play active role in protecting its users from crime, and it should avoid developing technologies that has purely criminal usages. And that's a moral rather than legal view. That's what I'm taking. And it doesn't mean, even if technology is created in a way that I think you follow what I'm trying to say. I think the prosecution of tornado developers is completely wrong and corrupt, and the legal system should not be doing it, right? It stifles innovation, it stifles investment, it has more harm than good, and in no case the developers of technology rather than service providers should be prosecuted for whatever usages this technology has found. That's my very strong view, which doesn't mean that technology developers shouldn't put some thought into how to protect their users from crime and how to prevent criminal usages. And again, it's not because they're legally obliged, but because I think we are morally obliged to find the ways that protect our users. Earlier this year, for example, we published an approach that we're going to take how we can do privacy preserving content moderation. We believe that both community owners, but also server owners should have means to respond to user complaints and remove content that they find objectionable, illegal, or whatever from their servers. But it doesn't mean that it has to come by compromising user privacy. So we had lots of conversations about that, and it's very controversial. But what I'm thinking is we understand the risks, and we understand that there are some worrying legal developments, but we'll do our best to navigate it and to protect our users.
Yeah, I wish it was discussed more because it's a subject people don't want to talk about in the privacy world. How there are legitimate situations where there are bad things that are done that can actually be prevented within reason without even invading people's privacy. And I feel like that is something that should be discussed a bit more. One of the big reasons that we shut down our Matrix server back in the day was because we kept getting spammed with CSAM all the time from people online. It's a problem that many other people who host Matrix servers were having as well. And it's not a healthy community to ever be a part of or join, or my goal is for people to associate privacy and digital rights with something that's a universal thing. And then if they join a server or a community that we are officially endorsing that's part of us, and they get spammed with CSAM, that's just bad for everybody. It's just not a friendly environment. So I'm glad that that's something that's being thought about, because
we not just think about it. We're very active in developing measures to prevent criminal usages without compromising privacy and security on everybody else. I honestly think, right, like having been engaged with privacy community for 4 years, I'm going to say something extremely controversial, and I think, like, if I'm not yet hated enough, some more people probably will hate me for that. I honestly think that privacy community is compromised and corrupted as a whole. Hard to say by whom, but probably by big technology companies, and it really has completely lost its direction, right? So because ultimately any kind of leadership should do what benefits most people, and most people in the world don't care about privacy, right? They see privacy as a hurdle and inconvenience at best, and they see privacy as enabler of criminality at worst. Governments and mass media is very united in attack on the right to privacy using this perception, right? And what I see in privacy community is some reasonable people who really want to help everybody, educate people, explain them why privacy is important and why it's not a means to an end, but it really is the way to have individual security, right? Because imagine all your financial information becomes public. You're likely to lose some money. You're likely to become the victim of financial crimes, right? Or imagine that your children, like, whereabouts become public. again, you're putting the lives of your children at risk, right? So, and this is something everybody cares about, but I think privacy community is very focused on technological aspects of privacy and legal aspects of privacy, and completely doesn't talk to people about how it is a means to an end that provides people individual security and freedom, right? Ultimately, right? Freedom to live their lives without effect. And what we see is that the same lobby groups finance privacy advocates and chat control legislation, or nonprofits that lobby chat control. You can look at the list of nonprofits that are lobbying, actively lobbying chat control legislation, and the sources of funding are exactly the same. And what we got to is that privacy communities become completely isolated from the rest of the world. Literally doesn't care about the rest of the world. All it cares about retaining the narrative is that privacy is a great thing, everybody else is shipple. That's what we observe, right? So I honestly think that the narrative with privacy is dead today. And the best we can do is to focus our efforts into providing people individual security and technology that protects them, protects their lives, protects their children, protects them from cybercrime. We're not going to compromise on privacy, but again, I honestly think selling people privacy today is almost like selling people HTTPS. What is it? Who knows what's HTTPS? But you go to the website and you know it's secure because of HTTPS, right? You don't know what HTTPS is, you never heard about it, right? So I honestly want to be in a world when people don't know what privacy is, don't need to know that. They just use technology that protect them.
Yeah, there's a lot there. Yeah, I think, at least on my end, I think there are a lot of people who see privacy this way, and I see it a lot. I know a lot of the listeners on our show and stuff like this see it that way. I feel like the people who are chronically online all day, who like the identity becomes privacy, and then privacy is an end instead of a means. That's where you see the problem. But those are also typically the loudest people, so it's really hard to make sense of everything going on. But there are a lot of people who see it this way too.
100%. Look, I think what you do is really important because you're trying to connect the world of, and you're being criticized a lot for that. Instead of like being focused on the privacy elite, you're trying to connect those technological concepts. You're trying to connect the concepts of security to mass market people, right? So our like engagement with each other started that you said, I'm not going to recommend SimpleX app because it's not ready for our audience. Look, I'm not criticizing. When people said, like I said, that's fantastic because it means that this man cares about their audience more than he cares about like a small niche of privacy enthusiasts that nobody cares about, which is critically important, I think, right? And we see it in the same way. We want really to build technology that will benefit the majority of people and not purely a niche tool that can benefit only a tiny minority, and half of them will be criminal users, right? Unfortunately,
Yeah,
right?
it's a mindset shift that people need to make. So I just yesterday at the time of recording, I put out a video on how F-Droid put out a blog pretty much saying, hey, due to Google's new developer restrictions, it might kill F-Droid, the whole concept of F-Droid, because Google is essentially trying to end the whole...
horrible.
Yeah, of sideloading. And a lot of people in the comments, and I actually addressed this because I already did coverage for this back when Google announced this measure, and now F-Droid talked about it, and then I covered F-Droid's response, essentially. A lot of people are saying, well, guess it's time to move to a custom ROM. Or, good thing I'm going to move to a custom ROM now. Or, you know, it's all about, it's not about what's like the workaround. You know, it's not about what you can figure out to do for yourself. It's about the fact that like 99% of people are never going to install a custom ROM, don't even know what that is, don't even know what we're talking about. They don't know what sideloading even is as a concept. To them, installing an app is just going to the Play Store. And they don't actually know what they're losing because this is a pretty new concept to them. So it's much more important to figure out like how to take this message and apply it to 99% of people and make them realize, hey, there's this beautiful thing on your Android device you don't actually know about that Google's trying to strip away, which is going to, over time, ruin the ecosystem on Android, and you're not even going to see it happen. That's a better argument. That's something that needs to happen more than, oh, so how do we get around what's going on for each of you 500 people who know what you're doing? So side rant, but it is something I do see. But again, when you do speak to the right people, the message is a lot louder. Like that video I put out yesterday, it's reaching a lot more people than it would be than if I just said, here's how to get around the F-Droid restrictions that might happen next year. That'll reach not even 1/100th of the people as if you like actually speak to the masses. So I think it's the right approach you guys are taking as well.
Yes, and you're absolutely right, Henry, and we want to build technology for majority, and that's why we are looking again to raise more funding without losing control again. And this time we're going to do community-driven fundraise. There will be, again, we're going to innovate cryptocurrency space as much as we innovated messaging. So we have created a new design for payment solution for infrastructure capacity. There will be utility token raise next year. So there will be some big announcements from us this year. So we'll announce this with lots of details, how the payments work between, like I was talking before about B2B2C model, but that means that people have to pay for these services. So we figured out the design that protects privacy without going into any compliance and financial regulation territory. So yeah, that's. I think it's really important to build technology for a wide range of users, because then it can have security, then it can have resources to provide utility, and it's simply impossible. If you stay in the niche, you die in the niche. You simply never get enough resources to get a high quality product. People compare what we do with Telegram, but Telegram has 100 times more investment in the product, right? Or WhatsApp, which has 500 times more investment into the product yet. So it's literally impossible to build great and polished user experience with the niche users, right? You need to grow beyond this niche to improve quality for everybody. So yeah, that's why it's important to build for everybody.
Yeah, so what's next for you guys? You kind of teased a new payment thing, but is there anything else that people can expect that you can share?
Our current focus is channels, development focus, right? So people will be able to host Telegram style channels that actually will work and scale to tens and probably hundreds of thousands of followers. We see a lot of interest from Telegram communities to migrate to SimpleX network, exactly because it gives them ownership of content, ownership of the audience, and the control and security. So that's one big development that should land this year, and at least as some beta experiment. And for utility token issuance, this is something that will happen next year. Preliminary we plan end of March. But there will be a preliminary registration for this token raise. So we're kind of working on the detail of this, and the announcement should happen within probably this month. We don't have exact date for this announcement.
We're
So
recording
we
early October, if all future people are listening to this.
Yes, so we may even, if it goes live in about a month, we may even have the link to the announcement put next to the video, what we're talking about. But I think it's great because I looked at lots of token issuances and they all look like a scam to me, frankly, right? Lots of money being pilfered by the people who create tokens. We literally want to create a utility token that will have one current and variety of future usages that will be used to develop and to provide the technology, where the team will not get any extraordinary financial rewards and no tokens allocated to the team, other than just from growing the business, growing the technology, growing the network. So super transparent, super focused. So we effectively will be doing token issuance in a very, very focused way, and it will be used to both provide some services straight at the point of issuance. So that's why it's utility token. So people will be able to pay for channels and for communities to increase hosting capacity, to increase the number of members it can hold. So yeah, but that will also allow to develop the future technology when the same payment mechanisms will be able to provide payment security and privacy. So effectively, even if you use usual money to pay for your community, you still can preserve the privacy of your identity. That can be very important for some situations. So you may publish completely legal content, but it may be sufficiently controversial and you don't want to be exposed, right? And if your payment connects to your usage, then somebody can leak this information, as we've seen happening, right? And then people get attacked in real life for their opinions they publish online. So I think for freedom of speech, it's interesting that my whole motivation for developing this network was not privacy. I never thought privacy is an interesting thing, frankly. I was more interested on freedom of speech. I historically have a long history with publishing. In my old life, I owned magazine. I worked in several publishing organizations. Then I led development team in Mail Online. So to me, publishing and freedom of speech and messaging are all like two sides of the same coin. And I was looking for technology that can really provide freedom of speech and control to small publishers, right? Because there is literally no platform in the world when a small publisher, an individual journalist, can engage with their audience and have control of this audience, right? So that like whoever gives them servers can't delete them from existence, right? Like it happens on social networks, right? So they either have to trust Facebook or Twitter to not delete them, or they have to go to work to some large publishing organization which will have their own views about what's right and what's wrong. And to me, it's interesting that we started at approximately the same time as Nostr. If you look at like the first paper about Nostr, it was published pretty much at the same time we had the first design of the protocol. But to me, it was more important to protect people real identities to achieve freedom of speech than to provide technical censorship resistance. Because Nostr focuses, okay, let's put the content on multiple servers so it's hard to delete. That's simple. I was always seeing it as a simple problem to solve, and that's not the core problem. The core problem is not content being deleted, but people being attacked in real life, right? Their bank accounts being closed, or they're being fired from their jobs because they say something unpopular, right? Or they literally get physically attacked in real life. And if you really want, you know, like Oscar Wilde said, you want somebody to say the truth, you give them a mask. If you want the man to say the truth, you give this man this literal quote from like more than 100 years ago. Nothing's changed, right? It's only possible for people to be open and honest about their opinions if their identities are protected. It's really hard to discuss controversial subjects if your identity is known. And it's very important that we can discuss those identities freely and securely, because otherwise society will stagnate. It wouldn't be able to get better, right? So that's fundamentally the mission and the vision and what keeps us working.
Right. So if people are interested in you or SimpleX, where can they find you?
I have a website called simplex.chat. There is an app called SimpleX Chat on app stores. You can connect to our tip right by the app. You can find some communities on the SimpleX network-wide website. They're really interesting and vibrant discussions about interesting things. Most are focused on technology and cryptocurrency and privacy and security, but some also like about lifestyle. For example, there are like some communities about agorism or whatever. So yeah, so yeah, I think we have a very interesting, very small yet it's very early days. It's close to 500, less than 500 communities there or groups listed in the directory. We're very selective because we really have limited resources to observe, but they're great people. We're engaging with them and they're contributing a lot to product development as well. But I mean, opinions, advice, suggestions. So I'm hugely grateful to all these people who made SimpleX Network what it is. Without people, it wouldn't exist.
Very cool. Well, thank you for your time. I know we were recording 2 hours. It's going to be a long one.
Okay.
So.
Henry, I really appreciate you doing what you're doing. That's fantastic. Thank you so much.
Thanks, Evgeny.
And with all of that said, I want to thank you all for being here and learning more about how the technology you use works behind the scenes, and so you can better educate yourself as well as the people around you. I also want to thank Evgeny for being on. And if you like these free interviews and you want them to keep coming and you guys get a lot of value from it, consider supporting Techlore. We have a lot of ways to do it. There are free methods down below on our website, which include using affiliate links, sharing our content, and of course, there's paid options like becoming a Techlorean, getting access to some of our exclusive communities, and also getting access to early content and other things out there as well. So go check out all the ways to support Techlore, and thank you all for watching again. I'll see you next time on Techlore Talks.